All right, this is 2023, and I haven't recorded anything this year. This is Sajjad Afuri from Triple I Networking LLC, and now, yes, it's official and limited liability company. This is the very first course that I ever record. After that, this channel or production or whatever you can call it has become an official company. The course that I'm about to start right now is a short one. It will actually take from you like the amount of videos will, let's say, take a total length of 2 to 2.5 hours. That's it, maximum. Let's say 2.5 hours, and that will range between 8 to 12 videos. It was an on-demand request actually because I did produce the same course in a different language. In between parentheses, that would be Arabic because these are the two languages that I produce content with only for the past 5 years almost. And many have requested, please, it's either you translate this one, add some subtitles, or just re-record it. So re-recording will be the fastest. Just sit down again, talk about for 2 or 3 hours, and done. Maybe we will need some video editing. Anyway, who is the course meant or directed to? Beginners, 0 level. Not only, but anyone who has a misunderstanding with the technology of IPv4, who has some gaps or caveats regarding the understanding of design of IPv4, understanding the design of IPv4 or the IPv4 design, the Internet Protocol version 4. This is number 2. Number 3, someone is studying for the ENSLD, Cisco Certified Specialist Enterprise Network Design, maybe this exam as well. I think it has the code of 30420. 30420, the ENSLD. Plus, of course, the one and only CCNA students who are studying regardless whatever version. Now, nowadays, if you want me to be more honest with you, almost all the associate level courses are requesting you or requiring you upon or before entering the exam to be really, really smart, experienced, and fast with IPv4 design. With that, I mean the Cisco CCNA, the Juniper JNCIA, Huawei HCIA, MikroTik MTCNA, whenever you will find the letter A, whether it was meaning associate or administrator, they want you to be really fast in their exams when it comes to IPv4 question, because you will see so many IPv4 questions there. So I am re-recording this in 2023 after almost 4.5 years of my very first time recording such courses. Before that, I used to do it, let's say, on premise, not recording. But now, enough with the introduction, I'm starting the IPv4 design at the moment. I will talk a lot about theory, and then I will talk about practice. By practice, I mean hands-on papers, not hands-on lab, because this is IPv4. We need to design the variable length subnet mask. We need to design the classless interdomain route or the classless interdomain routing, the CIDR, CIDR, or the CIDR block, CIDR domain, whatever you call it. I will not be talking about route summarization here because it's not really the right place for it. Route summarization, regardless that it can be done manually, not just automatic, but it's measured with wherever there is an OSPF summarization and filtering, let's say, an EIGRP summarization or filtering in a CCNP or a CCI course from the courses that I produce. Only there. But let's start right now talking about IPv4. If you have zero idea about it, or if you'd like to refresh, I'm starting at the moment. So the IPv4, the Internet Protocol version 4 that had no version 1, 2, 3 before. No such versions had ever seen the light before or the sunlight. No, at all. The very first version that humanity knew or heard about were the 4th version. There was no 5th edition, but there was the 6th as well. So we only have IPv4 and IPv6. And if you want me to be more honest with you, since 2016, we have been hearing rumors about IP version 9, yet we saw nothing. And you are still not seeing the exhaustance or the possibility of exhausting, let's say, IPv6 till the moment. Now, let's leave IPv6 for a later lesson. If you'd like me to, let's say, focus on a couple extra more hours on IPv6, we can record that later, not a problem. Today, IPv4. IPv4 is a layer 3 technology, or actually it resides at layer 3. It operates at layer 3 of the OSI layers, also known as the network layer from the perspective of the TCP/IP, let's say, model. Supported and carried by Ethernet frames. This one is also very important to understand. The IPv4 is a 32-bit in length, so this will consume 32-bit of the volume when you are trying to transmit or carry a single IPv4 over the medium of the network. The IPv4 is written in the decimal language, and I have wrote some silly, let's say, obvious note here, also binary. Everything is binary. Everything in the science and languages or language of the computer's world is binary, 100%. It's the binary language, 0 and 1. We are done. But I just said that here because I needed to focus on understanding how to read the IPv4 and the IPv4 subnet mask. Subnet mask is an acronym that I will make sure that you will master before you end this course, this short course or short series. So how to read these IPv4 and subnet mask in the binary language. It's super important to master the IPv4 is to understand how to fastly and efficiently be able to convert from decimal to binary and from binary to decimal. This is super important. Unlike with others, like you would rarely do that with MAC address, if you ever heard about that, and it will be even more rare to do it with IPv6 addresses, if you ever heard about IPv6 addresses. But with IPv4, we need that as a CCNA, as the NSLD, as whatever associate level students studying or understanding IPv4 for the first, second, or third time. I have to master and understand the conversion between decimal to binary and binary to decimal. The fuzz, the big case of IPv4 is it's a logical address, is that it is a logical address. Pardon my accent for today. I haven't practiced English like for almost 9 months, 8 months so far. I'm sorry for that. But the problem is that, or the big fuzz, the case, the chaos, the brainstorming with IPv4 is it's that it's a logical address. What do you mean? With MAC address, I am super lucky that MAC addresses comes from the factory. I had a device here. This one is from Microtech. You can get this, imagine, for, let's say, if it was expensive, it will be for $25. Let's say that. If you got it from a merchant, it will be $20, $21. Anyway, like it comes from the factory with MAC addresses. The interfaces comes from the factory. This is a general worldwide rule, regardless of the manufacturer, by the way. Regardless of the manufacturer, they all come with MAC addresses. Whatever smart device comes with a MAC address from the factory, that by default I should not change or modify. Let's stick to that point only. So I have 4 ports here, all of them MAC addresses. I'm so lucky. Done. It cannot be duplicated. It's unique. It's agreed already, predefined. That's it. Done. But with IPv4, it's logical. That's why there is the acronym of design. IPv4 design, because we need to be super careful designing an IPv4 address to use, designing IPv4 addresses to use, an entire broadcast domain, multiple domains to use carefully. Avoid duplicating, looping, storming, whatever other issues that you might face in your career. This will be done as a very first step. Let's say step number 1, not step number 0, but step number 1 should be the careful design and understanding the efficient design of IPv4. So a logical address means that you have to design it. Design what? The IPv4 itself. I haven't seen an IPv4 so far. You will soon. So very soon. All right. Let's keep these videos so short. Let's say between 12 to 15 minutes maximum. It's variable. It's based on the need. It's not from the factory. It doesn't come from the factory. It's not predetermined. No, I am determining this. I'm determining all the aspects, let's say, and the specs of the IPv4. I need to be very careful when I'm designing an IPv4. Part of the IPv4 is for the network, the other for the host. Let's avoid that. And actually, the architecture of this IPv4 is the total length is 32-bit for the IPv4 alone. And it's based on, or actually designed to have 4 octets, each of 32 divided on 4 is, or divided by 4 is 8. Done. So what is that exactly? Well, this comes from the Latina, or the Latin, how to say it? I'm sorry, in English. The Latin word, I think the Latin word octa, which means 8. So octet is taking from the number 8 in here, meaning that the IPv4 is so far. Let me just summarize how the look of IPv4 should look like. I hope that you don't mind using the black board, let's say, with white colors or light colors. Sajjad said so far, decimal language, decimal. decimal, meaning that it has a characters ranging between 0 to 9, because the decimal language also comes from decim or deci from the Latin language, which means 10. So it's 10 characters: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Done. That's it. I only have these. Number two, Sajad also said the maximum or the standard, not maximum, it's the fixed, let's say, length of this address is 32-bit. Okay, he also said it's actually made of 4 octets. Each octet is fixed with 8 bits. So if I had a correct impression about how an IPv4 should be drawn, an IPv4 should be taken, it will be an octet dot. Is it always a dot? Yes. An octet dot, an octet dot, the 4th octet. This is how it should look like. And here I should see characters that comes from this language and this language only. Moreover, an octet means, let me take this line to here and let me jump to a different color. Hopefully it will be clear to you as well. An octet actually means 8 bits. What are the origins? The binary language is the origin of that, of all the, let's say, of everything in the computers. So the binary language is on the base of 2 when using the algorithms. This is a little bit math. 2 to the power of the volume that can be covered, the possibilities of mathematical numbers that can be injected, 8. So this will result in 256. Correct. So there are 256 possibilities that can be inserted or filled within one single octet. Correct. Starting from 0, because 0 is a decimal digit. So if I started from 0 and I was counting until I reached the last 256th digit, that will be 255. How? I have 4 digits starting from the digit 0. So it's 0 because it's countable in our domain, in the IT domain, and the IT knowledge, or let's say in the IT area, it's countable. It has a value 0, 1, 2, 3, 4. 4. So yes, this is the 5th digit that I have. This is the 5th finger on my hand. But it has the value of 4 because I started from 0. It has to be in that way. 0, 1, 2, 3, 4. That's why it is impossible, no matter what happens to this planet, no matter whatever changes in the IPv4 design, it is impossible to see the number 256 in an octet. You can't. You will never see that. You can't. You just can't. The architecture of this, let's say, this address, the design of this address, it has to be only and only 256 possibility, but starting from 0. And of course, there will be no negative numbers in here. We are not going below, let's say, to the negative line. Starting from 0 up until the 256th digit, that will be the number, the numerical value of 255. So just an introduction. Yes, each octet can have a number ranging from 0 to 155. Regardless, we don't know. This is the idea. What I'm about to do, or let's say what I will be doing throughout this entire short course before I finish this video, because it has been too much for you, 40 minutes is more than enough, is that for every single screen that I find usable, I am taking a screenshot. Now just refer below to the description of this video. You'll find a Google Drive link. Clicking on that will show you the screenshots. You can just download them. You can just refer to them. You can maybe invert them and print it on papers, whatever you like, in order to use them to review your knowledge later. I am taking these screenshots in high quality just in case you ever thought that it might be useful. All right, let me take a screenshot. Done, and we will continue later.